Given f of x is 2x squared plus 1 and g of x is 2x plus 7, we want to determine an explicit equation. So I'm going to highlight that because that might be new terminology or something you've seen before, but we've got to talk about for each composite function. Then state its domain and range. Okay. First of all, an explicit equation. You know how we started this morning by doing the blue machine and the red machine? No, there was a blue machine and a green machine for our pots and pans and whatever it was. And then one of them broke and we had to get the red machine that did both of them. Well, that red machine was the explicit equation. It's saying instead of having to do one function and then the other function, what would the equation be so that you could just do it all at once? And the way that you figure out the explicit equation is you plug in x into one function, see what comes out, and then plug that entire answer into your other function. So again, we might show some work off to the side. We always work from the inside. So what is g of x? G of x is given to us. It's equal to 2x plus 7. So we don't need to show any work off to the side here. We know that g of x is 2x plus 7, so we can replace the g of x in A with 2x plus 7. So now we have f of 2x plus 7, because f of g of x is equal to f of 2x plus 7. What does f of 2x plus 7 say? Well, f of x says whatever number you would put in. If you put in a 4, f of x says square that number, multiply it by 2, and add 1. If you put it in 8, you would square 8, multiply it by 2, and add 1. If you put in something else, the function says whatever you put in. Because that's what this means. F of x says whatever you put in gets squared, gets times by 2 after that, and then you add 1. So if we put in 2x plus 7, the function says take that, square it, 2x plus 7 will get squared, it'll get multiplied by 2, and then you're going to have to add 1. Order of operations say first I'm going to have to square this. So 2x plus 7 times 2x plus 7 is going to give you 4x squared plus 28x plus 49. 2x plus 7 times 2x plus 7. You'd have to FOIL that. If you'd like to draw all those arrows and show more work, that's fine. But you will get 4x squared plus 28x plus 49. That then gets multiplied by the 2, which would give you 8x squared plus 56x plus 98. Still have a plus 1. So if we combine those like terms, we get 8x squared plus 56x plus 99. So if I want to do a little check to see if this is right, I could check something that mental math I could do easy. Can you see that if you plug in 0 for x, you should get 99 according to this equation? So I want to check, and this doesn't necessarily say, it could be by coincidence that I've got the same answer. But most likely, if you do a check like this and you get 2 different answers, then you might have done something wrong. So we're going to see, did we make a mental math error along the way or not? So if I did f of g of 0, what happens when I plug in 0 into g of x? I get 7. So this would be f of 7. And if I squared 7, that's 49. 49 times 2 is 98. Plus 1 is 99. It appears from checking that one number that it's the same. We could check other numbers to make sure, but it looks like we do have the correct equation in our math. So in part B, we want to find g of f of x. What's that? Oh yeah, we still state the domain and range. And the nice thing about the explicit equation is that it's not always hard, it's not easy to see what the domain and range is until you find the explicit equation. And in this case, our explicit equation isn't that nice to find domain and range from either, the way that it's written. So first of all, looking at f of x, can you see that that's a parabola? It's been stretched vertically by 2 and then shifted up 1. It would have a vertex at 0, 1. Its domain would be everything. Its range would be y is bigger than or equal to 1. Our second equation, 2x plus 7, is a line. It has a domain and range of everything. When we get this equation of f of g of x, what kind of equation is that? It's a parabola. What do we know about parabolas for domain? It has no non-permissible values. There's nothing that's not allowed to put in. Its domain will be everything. Okay? We also have to check to make sure that our original two functions had no restrictions. F of x had a domain of everything. G of x had a domain of everything. So that also implies that our function will have a domain of everything. So when checking explicit equations domain, you have to check the original domain of the function inside to make sure there was no restrictions on it, and then check your final equation's domain as well. To figure out the range of this function, this isn't nice. This is most likely in the textbook. There would be, say, you know what, feel free to use your calculator to find out the domain. What do we need to find out the range? What do we need to find out the range? We need to figure out where that minimum point is. Where's the vertex? And in this case, our equation isn't in vertex form. So we could do some old school complete the square. Or we could use our calculator to find that vertex. I can tell you right now, with completing the square, we will get some fractions. We will get some decimals. So I'm going to type this into my calculator right now, just to make it a little bit faster. We had, what was the equation? 8x squared? Yes? 8x squared plus 56x plus 99? Oh, thank you. Insert 6. Okay. We hit graph, see if we can see the vertex. There it is at negative 3.5, comma, looks like it's at 1, but we can now find it out. Second, calculate the minimum 3 between negative 5 and negative 1. Guess. And it is at y equals 1. So our range here is that y is bigger than or equal to 1. And despite the fact that our original function of f of x had a range y is bigger than or equal to 1, this is just coincidence that it happened to be the same. Nice. Okay. Part B. Just going to open up a new page for B. G of f of x. And f of x was given to us to be 2x squared plus 1. So we can write that inside right away. And g of x, the function of g of x, says whatever you put into g gets multiplied by 2, and then you add 7. So if we put in 2x squared plus 1, it's going to get multiplied by 2. Is it add 1 or add 7? And then we're going to add 7. So simplifying this, distribute your 2, you're going to get 4x squared plus 2 plus 7, which will give you 4x squared plus 9. So g of 2x squared plus 1 is equal to 4x squared plus 9. This is an easier one to tell domain and range. Again, the domain is everything. Our range, can you see that this has a vertical stretch by a factor of 4 and then been moved up 9? So our vertex would be at 0, 9, and the range would be y is bigger than or equal to 9, sorry. Finally, part C. Part C is asking us to find g of x. Well, g of x was 2x plus 7. And so now, again, the rule for g of x says whatever you put in gets multiplied by 2, and then you add 7. So if you put in 2x plus 7, that 2x plus 7 is going to get multiplied by 2, and then you're going to add 7. Okay. Once you see this, life is easy. Sometimes using highlighters can help with that. Here's the idea. This is our original function right here. Okay? And I've highlighted the x to say that the rule is whatever you plug in, which I've highlighted, gets multiplied by 2, and then you add 7. So if now, I'll highlight it in a different, now I'm putting in a 2x plus 7 in front of that. So it goes in right here. It's still going to get multiplied by 2 and add 7. And now you just need to simplify using your algebra. So this will be 4x plus 14 plus 7. 4x plus 21. So this becomes just a line. The domain of this function is everything. The range of this function is everything. Questions for practice are 10 and 11.